Hello and welcome to Maths with Jacob. This lesson will focus on Volume Part 2. In this video we will look at the volume of some pyramids as well as the cone and the sphere. Let's start by looking at the square pyramid. Now by its very name, the base is a square. So when I say that this length is B, all the four sides are B, and we know that the angles are at 90 degrees, etc., etc. So we know the properties of a square, so that's why I can just put B there. Now, here we have this dotted red line, and it's vertical. It's actually at 90 degrees to the base, and that's called the perpendicular height, and that is H. They are the only two measurements we need. To work out the volume, we just use this simple formula here. Volume equals a third by the area of the base by the height. That's basically it. It's very, very straightforward. And once you're given the necessary measurements, that's quite straightforward. We also have a triangular pyramid. So there are different types of pyramids, but I'll just look at these two. For the triangular pyramid, now the triangular base, I've just made a right angle triangle here just to make it straightforward. And here's the height again, and you can see this little symbol here, which means the height is perpendicular to the base. So, for example, if we have that length there and that length, let's assume that's the base and that's the height, and that's a right angle, we can find the area of the base, there's no problem, because it's just a formula for the area of a triangle. There's the perpendicular height, so the volume will be 1/3 times the area of the base times the height. So it's the same formula in each case, you just have different shapes for the base. For the cone, here's a very straightforward cone. Now we know the base is a circle, and we need the radius, of course, don't we? We always need the radius to find the area of a circle, and again, there's our perpendicular height. And believe it or not, it's the same formula, except the area of the base, that'll be the formula for the area of the circle, which is pi r squared. I didn't write that in there because we already know it. So because it's a circle, the area of the base is pi r squared. We multiply that by h and we find a third of that calculation. And finally the sphere. Now the sphere it's like a ball, perfect ball. Very symmetrical in all respects. It definitely does have a radius, and that's really all you need for the sphere, because the distance from that dot all around the whole sphere is the same. Remember, it's like a ball. So the volume of the sphere is 4/3 pi r cubed. And you'll always be given the value of pi. Sometimes it'll be the approximate value of 22/7, and sometimes it'll be 3.142. So this video has given us some basic examples where we have seen how to calculate the volume of selected solids. They're very special solids, and we've been given the formula for each of those solids, and whenever we find the answer, as we stated in the previous video, it's always in cubic units.